Yeah, good evening, friends, and welcome to interview preparation session. So today we'll be going through some of the questions from Python, basic Python. Okay. Okay. So let us go to our first question. What are the features of Python? What are the different features of Python? Yeah. So if anyone knows the answer, they can just ping me in the chat box. I'll be seeing, and then we can discuss afterwards. What are the features of Python? Okay, so some of the features are it is easy to understand and to write also. Okay, second, it is you can say this is object oriented. Language, sorry, object oriented language, functional, function oriented also. Yeah, correct, Sharan. It is free and open source. Yeah, that is also feature. Let me just add that free and open source. Then it is interpreted. Okay, it is dynamically typed language. Yeah, portable. It is portable, or you can say OS independent. Okay, doesn't depend on the OS. And what else? Yeah, rich libraries. You can say here community based. Python is a community based language. So the community always keeps on adding new libraries. So we have very rich libraries, you can say, in Python. Uh, Okay, last we can write it has a wide range of use. Okay, or in simple terms, you can say general purpose language. Okay, yeah. So coming to the next question. So we saw here, easy to understand, right? Object oriented, function oriented, free and open source. Then we had something called interpreted. So what is this interpreted? What is interpreted? Yeah, if anyone knows the answer, they can put it in the chat. Okay, Python program converted into bytecode. Yeah. So see what happens here. In programs where we require a compiler like C++, okay, we first write the whole program, then we run a compiler, okay. Compiler checks for error, then we go back, correct the errors, then again check for compiler. Then again, if compilation it is all correct, then we can go for running the program. But here, what happens? We have an interpreter. Okay, in Python we are having an interpreter which directly converts each and every line, means each and every instructions into bytecode, and this bytecode is understood by we have a Python virtual machine, PVM. Okay, that bytecode is easily read by this Python virtual machine, and it decodes it and reads the instruction and works accordingly. So here no compilation process is there. That is why, as we use an interpreter here, so Python is known as an interpreted language. Okay. Okay. Coming to the next question. Okay. Yeah. Next is this dynamically typed. Why Python is known as dynamically typed language? Yeah, Usha, correct. Okay. So why is it known as dynamically typed language? So basically, Python, in Python, unlike this C, C++, there is, we don't require to state the data type of a variable, basically. Okay. So like in C, C++, we used to write like int, a, then only we can use a is equals to, sorry, a is equals to 10 or something like that we could do. But here, if we directly write a is equals to 10, Python will know if it is an integer or a float or a string, means the data type is dynamically decided by this Python only. Okay, there is no need to write the data type of a variable. It is decided dynamically. Okay, that is why Python is known as dynamically typed language. Now coming to the next question, what is PEP? Okay, so PEP stands, PEP is Python Enhancement Proposal. Okay, so what is this Python Enhancement Proposal? Python Enhancement Proposal is a, you can say, it is a set of rules which tell us how to write a Python code, means which format to follow while writing a Python code, so that it will be, means it will give us maximum readability. Okay, so PEP, you can write PEP is Python Enhancement Proposal. Okay, I'm just repeating again. It is a set of rules which tells us how to format a Python code for maximum readability. Okay, coming to the next question. Okay, next question is uh, what are the built-in data types in Python? What are the built-in data types in Python? Yeah, I think it is an easy one. Okay, so first is numbers. Okay, then we have strings, then we have lists, then we have tuple, then we have set, then we have dictionary, and boolean. Okay, so numbers include integer, so we can write it is integer, float, and complex numbers. Okay, and strings are a sequence of character. We can write sequence of character. Now what is a character? Character is like a single alphabet in quotes. Suppose this A, it is a character. And what is a string? It is a sequence of character like apple. Okay, now what are lists? These are also sequences, sequence of different data types. So lists can have different data types in them. Similarly, tuples are also sequence of different data types. Okay. Then we are having set, which is you can say uh, an unordered set of different data types. Okay, but here there is no order. Then we are having dictionary. Dictionary are here the elements are present as a key value pair. Okay, and keys act as the index for the values. So if you want to call the values, you can call using the keys as the index. Okay, then we have boolean, which is like true and false. Also, we can use 0 or 1. Okay, 0 or 1 also we can use instead of true. So true value is 1, false value is 0. So let me write accordingly. So 1 or 0. Okay. Yeah, so let us go to the next one. So next question is, what is the difference between list and tuple? List and tuple. So what is the difference between list and tuple? As we saw here, list is also a sequence of different data types and tuple is also a sequence of different data types. So what is the difference? Both are the sequence of different data types. So why we are having a list and a tuple? We could have had one only. So what is the difference basically? Okay, so difference between list and tuple, first is representation. Okay, representation. So for representation, okay, list is represented with you can say square bracket, and tuples with uh, round brackets, okay, or parentheses. Now, okay, second is operation. Okay, operation, in operation, tuples are faster and list are, sorry, list are slower. Means if they are compared with each other, then doing the same operation. Yeah. Third is what Shubham has already told us. So third is uh, editable or not. We can say editable. So tuples we cannot edit, immutable. Okay, lists on the other hand are mutable. Now, what is this immutable mutable? Mutable means you can change you can say an element from a list. Okay, but these tuples you cannot change a single item. Suppose you want to change a single item in a tuple, you cannot do that. Instead, you can create a new tuple with that item which you require. But in list, that operation can be done. Means you can change a single item in a list. No need to create a whole another list. Okay, so now coming to the next question. Okay. Next question is, what is the difference between .py file and .pyc file? Sorry, this is dot. Okay, so what is the difference between .py file and .pyc file? Yeah, Trupti, lists are mutable. Yeah, but this PY, and what is the difference between this PY and PYC file? If you know, please, you can just put your answers. Yeah, Trupti, yeah, correct. Okay, so let me tell you what is this .py file and .pyc file. So basically, this .py file is, you can say, the Python source code files which you write. Okay, those files are .py files. Now, what is this .pyc files? So these are like the bytecode files which the interpreter converts for the machine to understand, or the Python virtual machine, you can say, to understand. So this .pyc file is the bytecode file for this Python virtual machine to understand. Okay. So this .pyc file are created when, you can say, interpreter reads the instruction and converts it into a machine readable format. So that is this .pyc file. Okay. So I'll just write it down. .py, you can say it is Python source code files, whereas this .pyc file is like our Python bytecode file, byte bytecode file. Okay, now coming to the next one. Yeah, next one is, what is slicing in Python? What is this slicing in Python? Okay, so you can say this slicing operation. Okay, this is uh, an operation. Okay, we use it for slicing a sequence. Yeah. Okay. Yeah, you're correct. So basically, to access a specific part of a sequence, sequence can be like list, tuple, or strings or range. Okay. So to access a certain part of the sequence, we use slicing operation. Okay. So the you can say this syntax of the slicing operation. Let me just write it for you. So syntax, yes, sorry, syntax. The syntax is like we use this square bracket operator for this, and here we give the start. Sorry, start. After start, stop, and after this we have step. Okay. So what are these? Start, stop, and step. So this start is the starting index of that subsequence. The stop is the stopping sequence, or you can say just plus one of that, whichever you want. Uh, Stop, and step size is like how many this element you want to jump. So suppose I'm having a string, suppose apple. Okay, I'm having this string. So let me make this a string. So suppose I'm having a string and I'm saying start is 0, stop is suppose 8, and step size is 2, suppose. So what it will do, it will take this a first. Okay, so our output will be a, then p, then e. So how is it happening? So first it will check our start and stop. So 0 starting from a is 0 to 8. So 8 is above the length of the, you can say, string. So it will take all the elements. Apple, it will take all of the elements. And this 2 is the step size. So what it will do? First, it will go to A, then jump one. So if we are having 2, so it will jump over 2 characters. So basically A and P, it will jump over those and go to P. Now, again, it will take this P, and again, it will jump over 2 characters again. Okay. So P to E. So we'll be getting this APE. Okay, if we run this slice, then it will get this A. And with this start and stop, we can control whichever up to which we want to calculate. So suppose if I did here, instead of 8, I wrote here, suppose 2, not 2, 3, suppose. So 0, 1, 2, 3. So up to this APP, it will consider. So one thing to remember. So this one, the start is inclusive. Okay. So this is always included. So whatever start you'll do, give, that later will be included. So here 0, we have started with 0. So A is included, but this stop is always exclusive. Okay. Exclusive means if we are giving 3, so 0, 1, 2, 3. So L is 3. This will not be included in our, not E. So this L will not be included. So whichever index we are giving as stop, that will not be included. Okay. It will just take APP. So if I didn't give any step size, I gave just 0 to 3, it will give us result APP. So this is how we can slice our sequences. So same works for list also and tuples also. Now coming to the next one. Okay, so what are keywords? What are keywords in Python? So in Python. Yeah, Shubham, correct. So they are basically reserved uh, words in Python. Yeah. So keywords, we can say keywords in Python are the reserved words, okay, that have some special meaning. And these keywords cannot be used as a variable. Okay, it is not cannot be, it should not be used as the variable name. Okay, and we have a total of 33 keywords in Python now. If you can just find out like some of the keywords, if I would like to say, like if, else, for, and, or, not. Okay, these are all keywords. So these keywords cannot be used as a variable name or a function name. Now coming to the next question. What are literals? What are literals in Python? So what are literals in Python? Also, you can add what are the different types of literals. Okay, so literal, sorry. Literal, we can say it represents a fixed value. Okay, it represents a fixed value for primitive data types. Now, what are the different types of literals? So if you see, we have 6 different literals. Okay. So what are those? Let me just write it down. Sorry, not here. Yeah. So first we are having a character literal. Okay, character literal is like a single digit character. So basically suppose A. So this represents a character literal. Then we are having, so these are like primitive data types. Okay. So whatever data types we had earlier, so those data types are known as this literals. So character, then we are having string literal. Okay, which is again like a sequence of these characters. Then we are having numerical. Then we are having boolean. Okay, then we are having literal collection. Okay, this literal collection consists of list, tuple, I think set and dictionary. Okay, set and dictionary literals. So these are all literals. Okay, and apart from these 5, there is a special literal in Python which is none type. Okay, so these 6 literals we are having in Python. So it is same as we can say this data types which we saw earlier, same, but these are like primitive data types which we had earlier. Okay, so coming to the next one. So next question is, how is memory managed in Python? How do we manage memory in Python? So Python is having a very efficient memory management. So how does it do? How does it manage memory? So for memory management, okay, for memory management, Python uses 3 things. Okay, first is the Python private heap space. Okay, Python private heap space. Okay, so what is the work of this Python private heap space? What it does is it all the objects which are in Python, okay, they are located in this private heap. So the Python interpreter, it you can say it allocates this which Python object where it will be used. Okay, so this the programmer doesn't have access to this private heap space. It can only be accessed by a Python interpreter, and it allocates so this basically these objects wherever it is needed to be allocated. This is done by Python interpreter. Okay. So next is Python memory space, or you can say memory manager. Python memory manager. So what is the work of this Python memory manager? So, so this private heap space contains all the objects. Okay. So this allocation of heap space for this objects. Okay. This is handled by this Python memory manager. So it allocates the memory for these objects which are stored in this heap space by Python's memory manager. Now, third, we are having garbage collector. Garbage collector. So what is this garbage collector? So this what it does, it recycles any, or you can say all of the unused memory, okay, so that it can be allocated to the heap space. So this garbage collector, it recycles all the unused memory. Okay, and these three together efficiently manage the memory for Python. Okay, coming to the next one. So next is how do we combine two data frames? So this is how do we combine two data frames? Okay, concat function, yeah. Okay, for this we have two methods. One is merge function. Okay, another is concat function. Okay, this merge function can also be used to merge two data frames, and this concat function can also be used to merge two data frames. Concat function, with concat function, either we can merge the data frames vertically or also horizontally. Or vertically means if we are having a data frame, suppose we are having data frame A, okay, and another data frame B. And we are doing this row wise merge, suppose. So in that we'll be having a parameter known as axis. Okay. So if we keep axis as 0, this B will be concat if we are doing A comma B. Okay. So this A will be there, and then it will be B will be concatenated here, row wise basically. Okay, these are rows. So now B will be here. But if we keep axis as 1 instead of 0, suppose we are keeping axis as 1. So now concatenation will be like this. Okay. So A will be here and B will be here. So concatenation can be done either this vertically or horizontally also. Merge, we can merge using a key. So if we are having a similar column in both A and B, we can merge them on the basis of this key. Okay. And here we can use the join function. Okay. So if we want the elements for both A and B, we can use total join. If we want the elements from I means common elements from A and B, we can use inner join. Okay. So like SQL, whatever joins we are having, inner join, outer join, all these joins can be used with merge function also. Now coming to next question. Okay, next question is, what are local and global variables? So what are local variables and what are global variables? Okay. So local variables are those variables which are present inside a function or a loop, you can say. Okay. If it is present within a block of code, like a function or you can say a loop. Okay. So those are known as local variables. These variables cannot be used outside of that function. Okay. Now, what are global variables? So global variables are those variables which are present in the global space, or you can say so it can be used anywhere in this program or program. It can be used anywhere, whereas local variables can only be used inside the function where it is declared. Okay. So that is the main difference between this local variables and global variables. Now coming to the next question. What are Python modules? So what are Python modules? Okay. So this Python modules, you can say are libraries. Okay, are libraries which contain a block of code. Okay, so these codes can either be a function or it can also be a variable. Okay, so these block of codes can be called after importing these modules. Okay, after importing these modules, you can call the functions which are present inside this library or modules. So if we say some of the modules, okay, so what are some examples of the modules if someone asks? So you can say modules are like we are having math library, random library, okay, date time library, and commonly used is like OS library, system library, SYS. Okay, all these are modules. Okay, so again, I'm just repeating what are modules. So modules are libraries which contain some Python codes. So these codes can either be functions, okay, or variables. So these functions can be called after importing this library or modules. Okay, after importing this library and or modules, we can call these functions from these libraries. Okay, so these are Python modules. So I think for today we are out of time, so we'll stop here. And yeah, we will meet again tomorrow with some basic questions on data science. Yeah, friends. Yeah. Good evening and yeah, bye.